Hello, my name is Isaac Tetteh-Apotey, and this is my project demo for the Artificial Intelligence Engineering course at Quantic School of Business and Technology. Today, I will be demonstrating my Retrieval-Augmented Generation RAG application called the Acme Policy Assistant. This application answers questions about company policies using a RAG-based architecture. Let us follow along and see how it works. Thank you. The application is deployed live on Hugging Face Spaces. Here is the chat interface where users can ask questions about company policies. The system uses 15 synthetic policy documents covering topics like PTO, security, paid time off, that's PTO, security, expense reimbursement, remote work guidelines, benefits of compensation, code of conduct, and many, many more. Let us explore the interface and then also input some questions about company policy and see how the system answers them. Let's start with a question about PTO. I will ask, how much PTO do I get after 4 years? So let's input that question and see how it retrieves and answers it. So the system correctly identifies that employees with 3 to 5 years of service get 20 days of PTO. Now, notice the citation. Notice the citation here. If I click on it, we can see the actual source document snippet showing the actual table from the PTO policy. So let's click on it. Okay, so this is the source snippet. So you can see that it says source 01 PTO policy.md. Now, let us explore with a security question. What are the password requirements? The system retrieves the relevant sections from the security policies and provides the correct requirements, as you can see in the response. So the answer is sourced from the information security policy documents. So you can see that it cites all the documents. So when you go to document number 2, let's see. So it cites this document. So the source is 02 security policy.md. Okay, so let us look at these 3. Okay, so it's the source is also 02 security policy. So it goes straight to the table and brings us a snippet from there. Okay, now let us move on with another question. So this time we would ask a question about internet reimbursement. So let's say we want to ask, do I get internet reimbursement for remote work? So let's ask this and see how it goes. So let's see. Okay, it says yes, you are eligible for an internet reimbursement. So we can see that the response have come. Now we will look at some out of scope questions. So let's look at let's ask a question that is not in the company policy. That is what we call the guardrail. So the guardrail is one important feature that prevents the system from answering questions out of the policy corpus. If I ask about the weather, the system politely declines. Let's look at this. So let's ask a question like, like what is the weather today? And then wait for the response. Okay, so I can only answer questions about Acme Corporation's employees policies. So we can see that the system politely declines and explains its scope. This ensures that users stay within the intended domain. Okay, so let's look at something like greetings. So let's say hello. Once we say hello, the system is able to respond to greetings. Yes, so we can just say greetings in its response to greetings. But once the thing is out of, the question is not within the company policy, it will just politely decline and then help user to know its scope. Okay, so we will move to the next. The next thing we want to explore are the citations and sources. So a key requirement was providing citations. Every answer includes references to source documents. As you can see, each citation expands to show snippets from policy documents, allowing users to verify the information. This builds trust in the system. Let us look at it. So from here, this is the citation. So when you click on it, then it shows you the snippet from the table in the reference document. So click back on it and then it comes back to the response. So if you click on this citation, it takes you to the snippet from the table in the source document. Yes, so you click on it again, it brings you back to the response so that if you want to make any reference, it can be easy and user-friendly for you. So if you do not want the sources to occupy the whole canvas, you can just minimize it and then you can just maximize it again. So that is for the citation and sources as required for this project. Let me briefly explain the architecture. Now let me show you the key files that helps in this RAG-based app. So let us look at the SRC. So you can see that we have the embeddings, we have the config.py, the evaluation.py, generation.py, ingestion.py, retriever.py, and then vector store.py. Now, what happens is that the application follows a standard RAG pipeline. First, documents are ingested and chunked. We have 15 policy documents that get split into 110 chunks with 1,000 characters each and 200 character overlap. So let us look at the policy documents. So these are let's look at the policy documents. So you go to data policies, we can see them. There are 15 of those. Okay, so secondly, we use the all mini LM-L6-V2 embedding model to create vector representations of each chunk and store them in ChromaDB. Third, when a user asks a question, we embed the query, retrieve the top most relevant chunks, and format them with citations. So then finally, what we do is that we send a prompt with the context to OpenRouter using the stepfun slash step dash 3.5 dash flash free model, which generates the answer with the citations. So that is how the architecture works. Let us look at the next feature, which is going to be the CI/CD and deployments. The application uses a fully automated CI/CD pipeline via GitHub Actions. Let us open GitHub Actions and see how the application was deployed. So Actions. Okay, so this is the latest workflow. So let's open it. Okay, so every push to the main branch runs tests, builds the Docker container, and deploys to Hugging Face spaces automatically. You can see the workflow history with all successful deployments. So this is the latest. And then these are the other successful deployments. Now, let us look at the Hugging Face space. So this is the Hugging Face space. So whenever the CI/CD runs successfully, this repo gets updated and then the app gets the latest update. Last part that we want to explore is the evaluation results. The evaluation results. For evaluation, I tested the system with 30 questions covering all policy categories. Each question was run 3 times to get a reliable latency measurement. So let us go to the GitHub repo and then look at the evaluation results. Okay, so we come here and then we go to evaluation. Let's look at the test questions first. So the test questions. So you can see 30 test questions. Now, let's look at the results. Okay, so this is the evaluation results. Okay, now let's try to explain what we see on the screen. So the latency metrics. So when we look at the latency, we say that you see the P50 latency, which is the median response time, is about 8 seconds. The P95 latency, meaning 95% of requests completed within this time, is about 13 seconds. Okay, so these numbers come from running 30 questions 3 times each, totaling 90 requests. The P50 of 7,964. See the 7,954 milliseconds gives us 8 seconds, and the P95 of 12,895 milliseconds gives us about 13 seconds. For a free tier API like OpenRouter, this is actually reasonable. The variability you see from a minimum of 4.6 seconds to a maximum of 38 seconds reflects the nature of free tier cloud services where resources are shared. During peak times, you might see longer waits, but the median performance is solid for a question answering system. Okay, So let's look at the citation. Or no, let's look at the groundedness first. Okay, let's look at the groundedness. So for groundedness, which measures how much of the answer is actually supported by the retrieved document, we got 52%. So we got 52%. Okay. This means the LLM stays grounded about half the time. While there's room for improvement, it's a solid baseline for a free tier model. Great. Now let's look at the citation. The citation accuracy of 14% correctly points to the exact supporting passage. This is an area for improvement, but the system does provide citations for 73% of all answers. These metrics gives us a baseline to improve the system in the future. In conclusion, this RAG application successfully answers policy questions, provides citations, and is deployed with a full CI/CD pipeline. Thank you for watching. I am happy to answer any questions about the implementations. Thank you.